Hello, Lab Busters, and welcome to Metric Mania, where I'm going to lead you through a lecture on the metric system so that you can understand the units of measurement that we will be using in science class or in Lab Busters class. What I want you to do is get out a piece of paper and a pencil so that you can take notes. If at any time you feel the video is moving too quickly, please feel free to pause on the screen so that you can finish copying the notes from the slide. Let's move ahead so that we can get moving with our metric system learning. Let's start off with comparing the English system to the metric system. So let's look at which one is longer, 1 mile or 1 kilometer. If you said 1 mile, then you would be correct. If we compare 1 yard to 1 meter, the meter is longer. And finally, if we compare 1 inch to 1 centimeter, the inch is longer. Now, the metric system, we are focusing on length on this slide. The basic unit of length in the metric system is the meter and is represented by a lowercase m. Metric units include kilometer, which is equal to 1,000 meters, the meter, which is equal to 100 centimeters, and 1,000 millimeters is equal to 1 meter. Now, let's compare which is larger. Letter A says 1 meter or 105 centimeters. If you said 105 centimeters, you would be correct. Letter B is comparing 4 kilometers to 400 or 4,400 meters. If you said 4,400 meters is larger, then you would be correct. Letter C is taking a look at 12 centimeters or 102 millimeters. If you said that 12 centimeters was correct or larger, you would be correct. And the last one is 1,200 millimeters compared to 1 meter. If you said 1,200 millimeters is larger, then you would be correct. Now, when measuring in the metric system, we will be using mainly centimeters and meters in class. But at some point, you may need to convert to millimeters. You should know that 1 centimeter equals 10 millimeters. So what is the length of the line below in centimeters? If you said 2.8 centimeters, you would be correct. Now we need to convert this to millimeters. What is the length of the line in millimeters? That would be 28 millimeters. What would the length of the line be to the nearest centimeter? We would round up so that we don't have any decimal involved in our measurement. And the answer would be 3 centimeters. The second part of the metric system that we're going to take a look at is mass. We're going to start off by comparing the English units to the metric units. So which one would be larger, 1 pound or 100 grams? If you said 1 pound, you would be correct. If you are comparing 1 kilogram to 1 pound, the kilogram is heavier or larger. And then finally, 1 ounce is more than 1,000 milligrams. The metric system for mass refers to the amount of matter. Let me repeat that. Mass refers to the amount of matter in an object. The basic unit of mass in the metric system is the gram and is represented by a lowercase g. Metric units include 1 kilogram, which is equal to 1,000 grams, and 1 gram, which is equal to 1,000 milligrams. If we compare which one is larger, let's take a look at letter A. 1 kilogram or 1,500 grams. If you said 1,500 grams, you were correct. Now let's compare 1,200 milligrams to 1 gram. If you said 1,200 milligrams, you are correct. Letter C compares 12 kilograms to 12 milligrams, and 12 kilograms is correct, is larger. And then finally, letter D, 4 kilograms versus 4,500 grams, and 4,500 grams is in fact larger. When measuring mass, we use a triple beam balance most of the time. Some schools and universities have electric balances that can be used, and you do not have to do any work. You just push a button and it'll give you the mass of the object. But at Martin, we tend to have we do have some triple beam balances that we may need to use. All you do is you take the different masses, and it's always in grams, and you set it to where the line balances next to the arrow on the scale on the far right-hand side. Once you have balanced the scale, you add up the amounts on each beam and find the total mass. So if we take a look, I'm going to start at the top mass, and that said 70 grams. Then I'm going to take a look at the middle mass, which is on 300 grams. And finally, the smallest mass in the front here is on 3.4 grams. So if we add all of those up, we get a total of 373.4 grams for this particular object. The final part of the metric system is volume. Volume is, we're going to start off with comparing the English to the metric system. So which one is larger, 1 liter or 1 gallon? If you said 1 gallon, you would be correct. Letter B, 1 liter or 1 quart. The 1 liter is more than the 1 quart. And finally, 1 milliliter or 1 fluid ounce. The 1 fluid ounce is larger. Volume is the amount of space an object takes up. The base unit of volume in the metric system is the liter and is represented by a capital L, or it can be a lowercase l as well. Metric units include the liter, which is equal to 1,000 milliliters, and 1 milliliter is also equal to 1 cubic centimeter, or 1 gram. Now let's take a look at which is larger, 1 liter or 1,500 milliliters. If you said 1,500 milliliters, you would be correct. Letter B, 200 milliliters or 1.2 liters. If you said 1.2 liters, you would be correct. And finally, 12 cubic centimeters or 1.2 milliliters. If you said 12 cubic centimeters, you would be correct. Now, when measuring volume, particularly using water, we use something called a graduated cylinder. In order to read a graduated cylinder, you should measure at the base or the bottom of the curve of the water. This is called the meniscus. When using a real cylinder, make sure that you are eye level with the water in order to measure it accurately. If you are not eye level, you can get an inaccurate reading. What is the water volume of this particular cylinder directly to the left? If you said 43 milliliters, then you would be correct. What causes a meniscus curve, though? A meniscus curve is caused because the molecules of the liquid or the water are attracted to those of the container. The glass literally attracts the water to the sides and it causes this curve. Finally, let's practice measuring liquid volume. These are 3 examples that do not have a meniscus curve, but you do need to pay attention to the scales of these graduated cylinders. So letter A is measured in at 52 milliliters. Letter B measured in at 37 milliliters. And letter C measured in at 23 milliliters. Now, when measuring solid volume, you can actually use liquid to measure it. So when you find a volume of a regular object like a cube, all you need to do is multiply length times width times height. If we were to do that for the cube to the left, we would take 8 centimeters, times it by 10 centimeters, times that by 9 centimeters, and get a total of 720 cubic centimeters. But what happens when the object is an odd shape that we can't measure the length, width, and height? We can use water displacement to measure the volume of the object. We can see how much the water moved when we placed a particular object in water. So if you take a look at the right, we'll measure the amount of water with the object in it. And if you take a look at the graduated cylinder, it measures in at 280 cubic centimeters. Now we need to take a look at the graduated cylinder without the object, and that measures in at 200 cubic centimeters. All you have to do to find the volume is subtract the two and find the difference of the water levels from the one with the object in it to the one with the object that is not in the water. And if you do that, you will get a volume of 80 cubic centimeters for this particular object. Now, in the next video, I'm going to show you an easy way to convert the metric system from one unit to another. This is a very common mnemonic in order to help you remember the order of the units. And it goes, King Henry died by drinking chocolate milk. King stands for kilo. Henry stands for hecto. Died stands for deca. By stands for the base unit, which would be meter, gram, or liter. Drinking stands for deci. Chocolate stands for centi. And milk stands for milli. This chart is very nice and it allows you to easily see the conversion rates for the metric system. Converting the metric system is literally just moving a decimal point, and I will show you that in the next video.